Howdy and welcome back. So let's go ahead and continue our discussion with acknowledging kind of a distinction between the public and private access specifiers and get into, some perhaps guidance on, or I guess motivation first as to why we have them, and then some guidance in terms of what should fall under each. So why should we even bother with it to begin with? Why not just make everything public? So these are going to be arguments against making everything public. The first is, okay, let's provide a clean interface to our users. So think about this. We have a list of behavior. That is the items that we'd like the user to interact with. We could go ahead and put that under public. Obviously, when we're implementing our behaviors, we're going to have a lot of additional functions that is going to go about to allow that behavior to emerge. In this case, those functions could be made private. The user will never see them. They won't interact with them. They'll simply be focused on the actual functions that describe that high level of behavior that's implemented through a series of private member functions. Furthermore, having this combination of public and private allows us to maintain invariance. For instance, we saw with constructors, and then accessors, mutators, and really any sort of function that is a part of the public interface. What we really want to ensure is that from the lifetime of the object, throughout the lifetime of an object, that any sort of changes to the underlying representation would go ahead and ensure that the values being assigned or otherwise, or things being done, respect that invariant and maintain it throughout, again, the lifetime. This also helps easing debugging a little bit when we have a combination of public and private, since only a fixed set of functions will afford access to the data. It might help us narrow down where if something is occurring, where it could be, where a problem could actually be presenting. Finally, to allow a change of representation. So if we allow this to only occur through, say, the public interface, again, we can ensure that the any sort of invariants on the representation are maintained. And furthermore, if we had we don't know who's using our type or how they're using it, so it is good to ensure that if we're going to allow the user to make a change of the underlying object's representation, that indeed it is a valid change in the sense that it maintains and respects any sort of invariance on that type. So data members, public or private. Should an attribute, so data member, be made public or private? So here's a little bit of guidance on that. If the value assigned to an object's data member will work, so any sort of value is valid, you could go ahead and just declare that data member under the public access specifier. However, in almost all instances, when we assign a value to some sort of data member, we need to check that value and ensure that it is a valid assignment. So in this case, any sort of those data members that need this additional layer of, I guess you could call it security, but need to be checked, should be obviously declared under the private access specifier, and the interaction with them should be through a well-defined interface that ensures that proper values, that their data members are being interacted with in the intended manner. Finally, talking about private data members, and I'm kind of thinking about here in terms of both, I believe, data as well as the member functions, is that making attributes private can help maintain the integrity of our data members by inhibiting the direct manipulation of their values. Interactions with private data members would be limited to the extent provided by the public interface. Likewise, if we had, say, private members, what that also means is some of the invariant checks that we might have to be made within the public interface don't have to actually be made if the outside world cannot interact with them directly. So if we want private attributes to theoretically be public, we've already seen how to do this. So if there's some reason to get the raw value stored within a data member, or if you're interested in updating that value or updating that data member and assigning it, say, a new value, well, we've seen that accessors and mutators would allow that functionality to be absorbed into our class. So with that said, we'll focus a little bit more on the kind of idea of a public interface. We'll jump into private member functions and finish with non-member helper functions.